This is the kinematics lesson on velocity time graph. So these are the learning objectives. So basically we'll be learning what is a velocity time graph and what are some of things that we can deduce from a velocity time graph. These are prior knowledge. Okay, so velocity time graph describe the velocity of the object with respect with to time. So in other words, it just charts the velocity of an object at different timings. Okay, so velocity is similar to speed. So through velocity time graph, we can interpret and deduce the acceleration of an object, and we can also actually deduce the displacement of object. But this will be for the next lesson. So we'll be looking at the following graph, the velocity time graph of the movement when it's at rest, when it is moving at uniform velocity, and when it's moving from with uniform acceleration. So at rest, it's very simple. The graph is just flat line at 0. Why is that so? Simply because object is at rest throughout the motion. It remains 0 at different timing, and therefore it's just a flat line at different timing. Okay, it will be 0. So it's extremely simple. So let's look at positive uniform velocity, how it will look like. Simply, it will be looking like this. If let's say the object is moving at a uniform speed or uniform velocity of 1.5 meters per second, since it will always remain at 1.5 meters per second uniform velocity, it will just be a flat line having a starting value of 1.5. So of course your starting value could be any value. Okay, it could be 3, it could be 5. Okay, but the idea is that it's just a flat line. So similarly with negative uniform velocity, it's exactly the same except that it is starting of a negative value. So if it's moving at negative value of 5, okay, sorry, over here this is negative 1.5. So it's moving left, okay, and it's just a flat line starting from a value of negative 1.5. Obviously, for uniform velocity is actually quite simple, but I want you to do a compare and contrast with displacement time graph. Okay, so you have these two graphs. One is a displacement time graph. One is a velocity time graph. Both look exactly the same, but you find that it is the movement of it is as described by these two graphs is actually very different. They look exactly the same, both a flat line of value 1.5, but they are describing what the motion they're describing is entirely different. A flat line in a displacement time graph tells you that the object is actually stationary at a certain position, which is 1.5 meters away from the origin. But a flat line in a velocity time graph is telling you that object is moving with a uniform velocity, so it's moving with a speed of 1.5. So even though the shape of the graph looks exactly the same, but they are telling you that the object is behaving differently. So what I'm trying to emphasize is that it's very important for you to, before you analyze the movement, you actually have to look at the y-axis to see whether is it displacement graph, velocity graph, or even acceleration graph first before you start to do any analysis. Next, we move on to uniform acceleration. What does uniform acceleration mean? It means that the object is always changing its velocity at a certain rate. So if an object has an acceleration of 2 meters per second square, it means that for every 1 second it will change its velocity by 2 meters per second. And if you assume that the starting velocity is 0, you will have the following velocity as time passes by. So from 0 to 2 to 4 to 6 and so on. So if you plot the graph of velocity time graph, you would get something like this. And from the data itself, you can infer that the object is actually moving or traveling faster and faster. So this will be the velocity time graph. For uniform acceleration, it would be a straight line graph. And if you calculate the gradient of this graph, it will also have the value of 2, which is actually the value of the acceleration of the object. So in this case, for velocity time graph, we can conclude that the gradient of the velocity time graph is the acceleration of the object. If you recall, it's actually similar in concept, is that the gradient of the displacement time graph is the velocity. But this time, if we talk about velocity time graph, the gradient is the acceleration. So right now let's do a comparison with different uniform acceleration. So similarly, let's plot the graph of the object, velocity time graph of the object with acceleration 3 and 1 as let's compare to 2. And we look at the difference between the gradient of the acceleration. Let's use a simulation. Okay, let's have this starting at 0 velocity. Okay, but the acceleration is, let's start from 2 as a comparison basis. Let's see. Okay, as expected, it will look something like this. Okay, so it's telling you that the velocity is changing for every 1 second, every 1 second, every 1 second, and so on and so forth. Okay, so let's store this and let's start again. Okay, let's plot for something that is same starting velocity, but this time around the acceleration is only 1. As you can see, the car is actually changing its velocity, still changing its velocity, getting faster and faster, but it changes at a rate slower as compared to 2. Okay, so this would be the pattern. And let's just store the data, and we'll do it for 3. Okay, so same thing, we have the same starting velocity, but we do it for value of 3. As expected, the gradient becomes steeper. So if you compare the different acceleration rate, having this center one is 2. Okay, having a value of 3 means that it's steeper gradient. Having a value of 1 is a gentle gradient. So it's consistent that the acceleration is the gradient of the velocity time graph. Okay, this was what was concluded. Similarly, we can compare the acceleration of the object by just visually comparing the steepness of their velocity time graph. So the steeper the gradient, the faster the object changes its velocity. But do note that the acceleration is not velocity, which means that having high acceleration does not necessarily mean that it has a high velocity. Okay. So acceleration is not velocity. Let's use this as an example. You find that object A, which is the green line, has an acceleration of 0. Remember, flat line. Okay, a gradient is 0. So for object B has an acceleration of 10 because it changes for every 1 second it changes by 10, 1 second it changes by 10, 1 second it changes by 10. Yeah. But if we can see that object B has a higher acceleration than A throughout, but the velocity of B from 0 to about 5 seconds is slower because at 1 second A is having a 50 meters per second, but B is actually 10, and so on. So velocity of B is actually slower than A. So only at time equals to 5 seconds then the velocity is the same. So actually this example just shows that high acceleration only means that the velocity is changing rapidly. In this case, A does not change, B changes by 10. So acceleration doesn't equate to the value of velocity. It changes the velocity fast. Okay, so right now let's go to negative acceleration. Just some revision. Negative acceleration means that it's changing its velocity in a negative manner. So using an example, assuming that object has an acceleration of -1 and starts with a velocity of 4. So having an acceleration of -1 changes means that it changes velocity by -1 for every 1 second. So this will be the data. So if we start from 4, then every 1 second later it will actually change by -1, -1, -1, -1, and eventually of course it becomes 0. So from the data we can infer that the object is actually traveling slower and slower as time passes. So we'll use a simulation of a person walking. So right now, same thing, velocity, I start at 4, acceleration is subtract -1. So the person is actually moving in this direction. So let's see what will happen. Okay, to the graph. Okay, let's focus on the velocity time graph. Oops. Okay, So you realize that the person is actually moving slower and slower and slower until it reaches about this particular distance, and this will be the pattern. So for negative acceleration, this will be as shown by the simulation. It will start from 4, 3, 2, 1, 0. So the gradient of the velocity time graph is also negative. Okay, and as illustrated by simulation, the person is slowing down and eventually will come to a stop. So in this case, it's because the velocity magnitude is getting smaller and smaller and reaches 0 at time equals to 4. But take note that the acceleration is negative, but doesn't mean that the velocity is negative. Throughout the motion, the person is actually always moving forward, as the velocity is always positive. Okay, until it reaches 0 at time equals 4 seconds. Right now we talk about how do we identify whether the object is speeding up or slowing down in the uniform velocity. If you refer to my previous lessons, negative acceleration does not mean that the object must slow down, and positive acceleration doesn't mean that object must be speeding up. Okay? It really depends on the current velocity of the object. If you don't recall this idea, I will strongly recommend that you look at one of my previous lessons on acceleration. And it can be summarized in the following table: positive and positive, negative velocity and negative acceleration. This will be the pattern. So you see that it is always positive velocity and positive acceleration means positive gradient. If it's negative velocity, it is having a negative acceleration, it is actually speeding up. Okay. If it slow down, if you have positive velocity and negative acceleration, positive velocity and negative gradient or negative acceleration, it becomes slower and slower. 10, 8, 6, 4, 2, 1. Likewise, if you have starting with negative velocity and you have a positive gradient, it will also mean that it's slow down. So negative 10, negative 8, 6, negative 4, 2, 0. Okay, so this is slowing down. Right now, you can actually also, of course, interpret a velocity time graph of more complicated, but it is actually just breaking down into different sections. So if I give you this velocity time graph and I would want you to describe the motion of the object for time 0 to 12 seconds, you can break them down into 3 parts. Okay, some guiding questions for you. When is the object at rest? When velocity is at 0. Okay, means that it's stationary. When is the object speeding up? And can you find the acceleration of this object? And when is the object slowing down? And also, can you find the acceleration of this object? When is the object actually traveling at constant velocity? So which time frame is the object traveling at constant velocity? Graph. Okay, so that's the end of this lesson. Next lesson we'll be talking about non-uniform acceleration of velocity time graph.